Okay, so we will talk about right triangles, Pythagorean theorems, distance formulas, and basic definition of trig functions today. Okay, yeah. So first, what's the Pythagorean theorem? Okay, what's the Pythagorean theorem? So we need to learn the triangle first, the right triangle first. Okay, so if you draw any right triangle, okay, so this is the right angle. Okay, this is the right angle. So the definition of the right angle is 90 degree. Okay, is 90 degree. So next week we will study radian measure and degree measure. Okay, degree measure. So it's also pi over 2 in the radian measure. Okay, in the radian measure. So what's the idea of a right angle? So if you look at a paper, all the corners of the paper, they are right angles. So the paper has 4 right angles. Okay, 4 right angles. So for Pythagorean theorem, so the important thing is the right angle and the opposite side of the right angle. So you stand from the right angle, look at the opposite side. Okay, the opposite side. So this side is called the hypotenuse of the right triangle. Okay, hypotenuse of the right triangle. So most cases we use letter C for the hypotenuse. Okay, so we also use the letter C for the right angle. Okay, right angle. So C is right angle, and this C is also the hypotenuse, the opposite side of the right angle. Okay, right angle. Okay, so the other side we call them A and B. Okay, A and B. So we assume this is angle A. This is side A. This is angle B. This is side B. Okay, side B. And the order of A and B doesn't matter. Okay, the order of A and B doesn't matter. Okay, so if you know something about triangles, so A and B, they are acute angles and they are smaller than right angle. Okay, they are smaller than right angle. So how do we see they're smaller than right angle? So you can look at a rectangle. Okay, you can look at a rectangle. Okay, so what's this right triangle? Right triangle means basically you cut along the diagonal of the rectangle. Then you get a right triangle. Okay, a right triangle. So that's why this is A, angle A, this is angle B. So they are both acute angle. They are less than 90. Okay, they are less than 90. So for a right triangle, we have 190 degree and then 2 angles which is less than 90. Okay, smaller than 90. Okay, smaller than 90. Okay, so now what's the Pythagorean theorem? Okay, what's the Pythagorean theorem? Pythagorean theorem is about the length of right triangles. Okay, so we have a squared plus b squared is c squared. Okay, so that's the Pythagorean theorem. Okay, so C side is the most important one, is the longest one, is the hypotenuse. Okay, hypotenuse. So Pythagorean theorem is the relation of the length of right triangles. Okay, length of right triangles. Okay, so let's look at a very easy example. Okay, let's look at a very easy example of right triangle. So if this is 3, this is 4, and this is 5. Okay, this is 5. So let's label the angle and label the length, right? So angle A, so this is A. Angle B here, so this is B. And angle C is right angle, so this is hypotenuse C. Okay, hypotenuse C. So the Pythagorean theorem tells us so A squared plus B squared is equal to C squared. So now let's check it. Okay, let's check it. So what is A? A is 3, so we have 3 squared. What is B? B is 4, so we got 4 squared. Is this equal to the C squared? So C is 5, the longest one, the largest one, so 5 squared. So this is 9 plus 16 on the left, 25. On the right, 5 squared, 25. So 25 is 25. Okay, 25 is 25. Okay, so that is true. The Pythagorean theorem is true, not for only special integer length triangles. It's true for any right triangle. Okay, any right triangle. So let me give you another one. So later we will study all these. Okay, all these special triangles. So let's say here is 1, 1, square root of 2. Okay, square root of 2. Okay, the order of A and B doesn't matter, so we can put A here, B there. But the C, the hypotenuse, has to be the longest side. Okay, longest side, the opposite angle of the right angle. Okay, so now the theorem is a squared plus b squared is c squared. So we got 1 squared plus 1 squared is radical 2 squared. So this side is 2, 1 plus 1. This side is 2. 2 is 2. Okay, 2 is 2. Okay, yeah, so that's the Pythagorean theorem. Okay, that's the Pythagorean theorem. So the reason people want to study Pythagorean theorem is we want to measure the distance. Okay, we want to measure the distance. So for example, this is the coordinate plane, right? This is the coordinate plane. So let's see, we have -3 here, and then we have a 4 here. Okay, this point has 5, 4. This point has -3. Okay, -3. So let's put 4 a little bit higher. So what's the length between this -3 and 4? What's the length here? Okay, what's the length here? So you see we can use Pythagorean theorem here because this is the right angle. So we have a right triangle in the plane. Okay, in the plane. So this is length 3, positive 3, negative 3 doesn't matter. That's only the direction. Okay, this is 3. This side is 3, the other side is 4. So C is the hypotenuse. How much is C? 3 squared plus 4 squared is C squared. Then we got 25 is C squared. You take square root, 5 is C. So this side is 5. Okay, 5. So the distance from this point, -3 to 4, is 5. Okay, is 5. So that's how people started to look at right triangles to create Pythagorean theorem. Okay, Pythagorean theorem. Okay, so now let's write down the general formula for the distance. Okay, let's write down the general formula for the distance. So if point A is x1, y1 in the plane, point B is x2, y2 in the plane, right? In the plane. So let's draw them. Here is A. This is x1, y1. Here is B, x2, y2. Okay, x2, y2. So now let's add this point C. Okay, add this point T. So what this point C? C is on the vertical line, so CB is vertical. So they have the same x, so this is x2. And the AC is horizontal, so they have the same y, so this is y1. Okay, this is y1. Okay, so now let's look at the length AC. Okay, the length AC is a straight line, horizontal line. So we just measure the difference of the x part. Okay, so AC is, this side is x2 minus x1. And the BC is the difference of the height, right? The difference of the height. Okay, so this is y1, this is y2. So their difference is y2 minus y1. Okay, y1. So what's the distance between A and B? Okay, what's the distance between A and B is the Pythagorean theorem, right? Pythagorean theorem. So hypotenuse is C. So this is A. That's the A side. That's the B side. So A squared plus B squared is C squared. So we got, sorry, here should be x1, right? x1. So this should be x2 minus x1 squared plus y2 minus y1 squared is C squared. So what's the distance C? You take square root, you got distance C. So x2 minus x1 squared plus y2 minus y1 squared is C. Okay, is C. So the distance formula, distance between A and B is x2 minus x1 squared plus y2 minus y1 squared, and then you take square root. Okay, you take square root. So this is the distance formula based on the Pythagorean theorem. Okay, based on the Pythagorean theorem. Okay, so let's look at an example. So if we have, so what's the distance between A is 2, 3 and B is -1, let's say 4. Okay, 4. What's the distance between A and B? So first you write down the formula. Distance A to B minus y1 squared. Okay, so what's x1, x2, y1, y2? So let's label them. So this is x1, y1, the first point. This is x2, y2. Okay, y2. So now plug in. So x2, -1, minus x1, 2 squared, plus y2, 4, minus y1, 3 squared. So we got, this is -3 squared plus 1 squared. So this is radical 10. Okay, this is radical 10. So let me repeat a little bit. First, you write down the formula. Okay, it's square root x2 minus x1 squared plus y2 minus y1 squared. So the difference of x squared plus the difference of y squared, and then you take square root. Okay, take square root. And how to find x1, x2, y1, y2? So x1, y1. So stop index 1 means the first point. Okay, x part of the first point, y part of the first point. So that's x1, y1. And x2, y2, they are the x and y part for the second point. So you label them and then you figure out the number. So x1 is 2, y1 is 3, you change them. x2 is -1, y2 is 4, so you replace, change them, plug in, you got the calculation, you got the distance. Okay, you got the distance. So that's the distance formula. Okay, that's the distance formula. Okay, yeah. So now let's look at two cases of right triangle questions. Okay, right triangle questions. So case 1, we want to find C. Okay, case 2, we want to find A or B. Okay, A or B. So there are 3 sides in the triangle. You are given 2 of them. Okay, 2 of them. So this is case 1. Okay, this is case 1 example. So let's say this is, let's use some random numbers, right? The random numbers. Here is 2, here is 3. So we want to find C side. Okay, we want to find C side. So we will compare the calculation. Okay, calculation. So now I'm going to change the order of 3 and 2. So let's suppose C is 3, A is 2. We want to find the B side here. Okay, B side here. So the other doesn't matter. Okay, the other doesn't matter. Okay, so first by the theorem, A squared plus B squared is C squared. So what do we got? So this is 2. So we got 2 squared plus 3 squared is C squared for the case 1. Okay, for the case 1. Okay, for the case 2, what do we got? A squared plus B squared is C squared. The same formula. So now this time A is 2, so 2 squared plus, we want to find B, so it's B squared. We don't know what is B, and then C is 3, so it's 3 squared. Okay, 3 squared. So now you can see the difference. So for the case 1, 2 and 3 are on the same side. For case 2, 2 and 3 on different side. Okay, different side. So case 1, we just add them, right? So 4 plus 9 is C squared. So 13 is C squared. Take square root. C is radical 13. Okay, radical 13. So case 2 is a little bit harder because 4 and 9 are on different side. So we got 4 plus B squared is 9. So minus 4, B squared is 5. Okay, B squared is 5. Okay, so take square root, B is radical 5. Okay, B is radical 5. So the calculation is completely different. Here we have addition. And then the case 2, we have subtraction. Okay, case 2, we have subtraction. So if you want to find the C side, the hypotenuse, you add A squared and B squared. They are given. Okay, they are given. So if you want to find A or B, you have to use C squared minus the given one. Okay, the given one. So this is how to use Pythagorean theorem to find the missing side for a right triangle. Okay, for the right triangle. Okay, so now we have the distance and we have the right triangle. So now let's define the trig functions. Okay, we have 6 trig functions. Okay, so for the 6 trig functions, the most important 3 functions are sine, cosine, and tangent. Okay, tangent. And all these 6 trig functions based on the given angle theta. Okay, so here the angle is theta. So let's mark it. The angle is theta. Okay, the angle is theta. So now in any right triangle except the right angle, you have 2 choices for the angle theta. Okay, for the angle theta. So you have to choose the angle theta first. Okay, so let's say this is the angle theta. And then you look at the opposite side of theta. Okay, so from theta, you look at the opposite side. Okay, so the side that's facing theta is called the opposite side of theta. Okay, and then theta has two sides. Okay, theta has two sides. One side is fixed, that is the hypotenuse. And the other side is called the adjacent side of theta. Okay, the adjacent side of theta. Okay, adjacent side of theta. Okay, so now let me use three colors. So hypotenuse, let's use the purple color. So this side, the longest side of the right triangle is hypotenuse. It's purple. And then the orange side is the adjacent side. So this is the adjacent side. So they make angle theta. Okay, between these two, purple and orange side is the angle theta. And the opposite side is blue. Okay, opposite side is blue. Okay, opposite side is blue. So now let me change the angle theta. Okay, so let's still draw the same triangle. But let's make this angle to be theta. Okay, this angle to be theta. It's the same triangle. Okay, it's the same triangle. But now I assign the topper angle, the top angle to be theta. Okay, top angle to be theta. Then what's the opposite side? So this is the opposite side now, right? This is the opposite side of angle theta. Okay, and then the hypotenuse is the same. We cannot change the hypotenuse. Hypotenuse is the opposite side of the right angle. So it doesn't matter you choose which acute angle to be theta, you got the same hypotenuse. Okay, hypotenuse. But this time the orange side is the vertical side. So this is the adjacent side. Okay, this is the adjacent side. So it's based on the angle. Okay, first you have to decide which one is opposite, which one is adjacent, which one is hypotenuse. Okay, which one is hypotenuse. Okay, so now the definition of sine. Okay, the definition of sine is opposite over hypotenuse. Okay, opposite over hypotenuse. So let's use the color. So it's blue. The blue side is opposite over hypotenuse. So that's the purple, right? Blue over purple. Okay, blue over purple. So cosine is the orange over purple. Okay, the orange over purple. So it's the adjacent side over the hypotenuse. So what's the last one? Tangent. Tangent is blue over orange. So opposite over adjacent. Okay, opposite over adjacent. Opposite. The blue side over adjacent side. Based on the angle. Okay, based on the angle. Okay, you have to remember all these three. So what's sine? Opposite over hypotenuse. What's cosine? Adjacent over hypotenuse. What's tangent? Opposite over adjacent. Okay, so the other three are the reciprocals of sine, cosine, and tangent. Okay, tangent. So what's cosecant? Okay, so cosecant theta is 1 over sine theta. So that means you flip it, right? You flip it. So this is the hypotenuse over opposite. Okay, opposite. So what is secant theta? Okay, what secant theta is 1 over cosine. So this is hypotenuse over adjacent. Okay, over adjacent. And what is cotangent theta? Okay, what's the cosine? Is 1 over tangent theta. You flip tangent theta. Okay, so it's adjacent over opposite. Okay, opposite. So we have 3 sides, 6 ratios, and they are our trig functions. Okay, they are our trig functions. So the most important thing is you remember the definition of opposite, adjacent, and hypotenuse, and then remember the first 3. Okay, the first 3. The other 3 are just the reciprocal of these 3 trig functions. Okay, trig functions. So let's look at example. Okay, let's look at example. So the most easy example, 3, 4, 5, right? 3, 4, 5. So this side is 3, this side is 4, this side is 5. Okay, this side is 5. So let's use A and B now because I need two angles. Okay, A and B. So what's the opposite side of A? Okay, what's the opposite side of A? Is 3, right? It's 3. So you look at A, this is 3. What's the adjacent side of A? Is 4. And hypotenuse is always 5. Okay, always 5. Okay, so now let's write down the 3. Okay, the first 3 trig functions of A. Okay, so sine A is opposite over hypotenuse. So this is 3 over 5. Cosine A is adjacent over hypotenuse. So this is 4 over 5. And tangent A is opposite over adjacent. So this is 3 over 4. Okay, 3 over 4. So this is for angle A. Okay, this is for angle A. So now for angle B is completely different. Okay, so let's look at this angle B now. Let's change the color. So for angle B, so what's the opposite side of B? Is 4, right? Opposite of B is 4. Adjacent of B is 3 and hypotenuse is 5. Okay, it's 5. So in the beginning, you may write down all these 3 sides and then write down the trig functions. Okay, so sine B is opposite of B over hypotenuse. So opposite over hypotenuse. So this is 4 over 5. Okay, you see sine A is 3 over 5, sine B is 4 over 5. They're completely different. Okay, they're completely different. So cosine B is adjacent over hypotenuse. So this is 3 over 5. And tangent B is opposite over adjacent. So this is 4 over 3, right? Opposite of B. So 4 over 3. Okay, 4 over 3. Okay, so the other 3 functions, you just flip it. Okay, flip it. Okay, so you have to be very careful. Which one is the angle and what's the opposite adjacent side of that angle? Okay, of that angle. Okay, so now let's look at a question in the web work. Okay, so this is A, this is B, it's not very clear, and this is C. Okay, this is C. Okay, and then the numbers, so I guess this is 100, and this is 96, and this is 20 something. It's 28. Okay, it's 28. Okay, 28. Okay, yeah. So now let's look at angle A. Okay, so what's the opposite side of A? Opposite of A. So this is 28. Okay, so this is A and then the opposite side of A. And then adjacent side of A is 96. Okay, 96. And then what's the opposite side of B? So this is B, so opposite side of B is 96. And adjacent side of B will be 28. Okay, 28. Hypotenuse is 100. Okay, hypotenuse doesn't depend on the angle A or B. Okay, hypotenuse is the C side, the biggest one is 100. Okay, yeah, so you write down A and B, opposite adjacent first, and then work on the trig function. Okay, so what's sine A? Sine A is opposite of A divided by hypotenuse. So it's 28 over 100. And then for the web work question, you have to simplify that. Okay, they are both even numbers, so it's divided by 2, 14 over 15, divided by 2 again, so 7 over 25. Okay, so what's cosine A? So it will be adjacent over hypotenuse. And then simplify that, 48 over 50, 24 over 25. Okay, 24 over 25. Okay, and then you can finish all other questions. Okay, all other questions. So you're given 3 sides, just use definition of trig functions to find the ratio and then simplify the ratio online, okay, for the web work. But for some questions, you are only given two sides, okay, you're only given 2 sides. Okay, so let's look at this question in the web work. So you know A and B, And they want to find the trig value. Okay, you don't A and B, they want to find the trig value. So A is 22, B is 24, and then they want to find the trig value. So what's your first job? Your first job is you use Pythagorean theorem to find C, right? To find C. Okay, yeah. So here is A and B, C. So A squared plus B squared is C squared. So it's 22 squared plus 24 squared is C squared. Okay, it's C squared. Okay, so what is 22 squared? This is 484 plus what's 24 squared? 24 times 24 is 576. So that's C squared. So the sum is 1060. That's C squared. Okay, that's C squared. And you have to take square root. Okay, and you have to take square root of that. That's C. Square root 1060 is C. Okay, is C. And don't worry. Okay, don't worry. You don't have to simplify this kind of radical. Okay, you don't have to simplify this kind of radical. So now let's write down sine and cosine, right? Sine and cosine. So this is A side. So this angle will be capital A. Okay, A side opposite to angle A, B side to opposite to angle B. So what is sine A? Opposite over hypotenuse. So it's A over C. So this is 22 over square root of 1060. Okay, so what is sine B? So it will be opposite of B, so it's B over C. So this is 24 over square root of 1060. Okay, 1060. Okay, yeah, and then you can use the definition to find the other two. Okay, cosine and tangent. Okay, cosine and tangent. So next time we will talk about 4 special right triangles. Okay, 4 special right triangles. So let's talk about one of them today. Okay, one of them today. So is 30-60 degree right triangle. So this is 30 degree, this is 60 degree, and this is 90 degree. The right angle, 90 degree. Okay, so it's 30, 60, and 90 degree right triangle. Okay, so this triangle is very special. Okay, this triangle is very special. So what's the length of these 3 sides? So it's 1, 2, and radical 3. Okay, 1, 2, and radical 3. You can check it. 1 squared plus radical 3 squared is 2 squared. So 1 plus 3 is 4. So it is correct. Okay, it is correct. Okay, so this is very useful. So how did we get this triangle? Okay, how did we get this triangle? So basically, we look at a triangle which has all 3 sides has length 2. And if you cut in the middle, so this will be 2, this will be 1, right? This will be 1. So that's the right angle. So we got 2, 1. Use Pythagorean theorem. We find this is radical 3. Okay? That's how we get this right triangle. Okay, right triangle. So this is one of our very important special angle right triangle. So even you don't know what 30 degree means, 60 degree means, 90 degree means, that's okay. Just remember it. That's the rule. Okay, that's the rule. So this triangle is special. They have special angles 30, 60, 90. And these are the lengths. Okay, these are the lengths. So now what is sine 30? Okay, what is sine 30 degree? So you look at the 30 degree and then go to opposite. So 1 over hypotenuse 2. Okay, so if you're not familiar with that, you can write down the definition: opposite over hypotenuse. Okay, so what's cosine of 30? So this is adjacent over hypotenuse. So this is radical 3 over 2. Okay, what's tangent? So this is opposite of 30 over adjacent of 30. So this is opposite 1 over adjacent. Okay, over adjacent. And when you look at 60, you will get a completely different answer, right? 60. So now let's look at the angle 60. So angle 1. So sine 60. So we look at angle 60 and then look at opposite. Okay, so this will be radical 3 is the opposite side over hypotenuse. Cosine 60 is the adjacent side over hypotenuse, 1 over 2. And tangent of 60 is opposite over adjacent of the angle 60. So this is radical 3 over 1. Okay, over 1. Okay, yeah. So today basically we have 3 formulas, or maybe 2 formulas, 1 theorem. Okay, you need Pythagorean theorem, a squared plus b squared is c squared. Let's rewrite them. So Pythagorean theorem, a squared plus b squared is c squared for the right triangle ABC, right? C is the hypotenuse, okay? C is hypotenuse. And then we use it to find distance, right? Distance is square root x2 minus x1 squared plus y2 minus y1 squared. Okay, that's the distance formula. And then we have definition of trig, right? Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And then tangent theta is opposite over adjacent. Okay, so we are looking at angle theta here. Okay, so this side is opposite side, and then this side is the adjacent side, and then hypotenuse side is that. Okay, so look at the opposite first to get opposite. Okay, and the adjacent side hypotenuse make the angle. Okay, make the angle, and the other 3 are the reciprocals of sine, cosine, and the tangent. Okay, so that's our today's lecture.